and welcome back to Research Methodologies. This is a continuation on the lectures of research design, and this lecture will be about the technical research design. So, before this, you should have watched the lecture on conceptual research design so that you have a basis of why you're researching it. Now we're going to talk about the how. So in the technical research design, basically what you're going to create is the set of activities that you are going to do, the actual research, to realize the objectives that you set out in your conceptual design phase. So basically, we're going to make decisions in this part about the how, where, and when. This is, for most people, the cool part, because that's when we get to start doing stuff. In there are basically three phases. What is my strategy? What is the material that I need? And how does it all fit in the timeline that I want to do it? When it's going to happen? When is what going to happen? So if we look at this a bit further, and we focus on the strategy, this is basically where you plan the way to approach your research, and you're picking the methods that you're going to use. Whichever method you're using, whether it is I'm just going to create a theoretical mathematical model, program it, and have results, and then validate it, or whether you're going to physically test, or whether you're actually going to do something scary and talk to people and interview them, all these are part of your strategy. It just depends what your assignment is. So when you choose your strategy, you really must take a few things into account. The suitability, that is of the method, but also of your skills. Can you actually do it? And the academic level of the problem. Basically, you do have to do something challenging. You also have to look at availability. Are the resources, such as the test equipment, available? And financially available. I mean, you may want to borrow the Cessna Citation for 5 weeks, but I can tell you probably already right now that that isn't going to happen, because even if it is available, it might not be financially available, if you know what I mean. Duration. Can it be done within the set time? If you want to do some sort of long-term observation experiment that's going to last 4 years, then I suggest you submit for funding for a PhD proposal, because for a master's thesis, it's way too long. Also, in the duration, can you actually use a certain set of equipment, or the cluster, for instance? If you want to run a job that, based on its computational power, is going to take 4 weeks, will you actually be given that availability at the same time? So all these things hang together. Also, feasibility. Can it be done at all at the TU Delft? If we don't have the research facilities, it's unlikely we're going to build it for you or buy it for you, especially if it's a large expense. It has to fit within what we can do. Or, if we are going to actually buy it, because there is some funding and it's part of a project for which we can actually claim back some of the money, what is the delivery time? If you have to wait 6 months for your equipment to arrive, then maybe this isn't a project for you. So these are all the things that you have to take into account. And then finally, also you should look into things such as ethics. Should it be done, and do you want to do it, etc. I'll come back to ethics in the next lecture. And there may be many other things that you really want to take into account when you start determining your strategy. It's also very important to see if your strategy is in line with what your supervisor expects. So again, this is a stage where you communicate a lot with your supervisor to ensure that you're both on the same page and are both in agreement. That is also why we really would like you to write your project plan, not only because you then learn how to plan your research, but it's also a document that allows you to go to your supervisor and discuss what it is that you set out to do and how you'd like to do it and why, etc. That is really where you're going with this. So, pick your research methods on a very high order level, because I can go into detail about every single research method. We're going to do CFD, we're going to do splines, we're going to do this, we're going to do that. Not talking about that. You are the specialist in your area. What I'm trying to say is go on a slightly higher scale, more helicopter view idea of the generic research methods that are there. There is the empirical research, such as survey research. There are the experiments. And experiments goes far beyond just standing in the lab or the wind tunnel. These can also be simulations, things you run on the computer. These are also experiments. You have a certain result that you'd like to get, and you run the simulation and you see if that is actually happening. The other thing is such a thing as case studies. And case studies is not always a piece of paper. It might be, for instance, design and build a drone that can pick up a parcel and deliver a parcel somewhere. your first thing that you can do, that the first one that makes one, is the proof of concept. So a case study can really be a small domain. It's the N is one domain where it's fine, I'm just proving that it works, and then somebody else can prove that it works over and over and over again. The other thing is what's called the grounded theory approach. You have seen something happening, or your supervisor has seen something happening, a sort of side phenomenon in something that he was investigating or she was investigating, and they have a theory how it works. So you start looking at that, well, if that's the case, let's see if I can develop this theory, and I write this theory out, and I find backing from literature that well, if this is true and this is true, then maybe this is also true, and you have a theory which you can then, from the ground theory approach, pose to people, and then the next step is, of course, to test your theory. And other things are things such as desk research. Desk research is something we all have to do. It is the paperwork that we most hate. It's when we have to go dig through the library, either physically or actually from a distance behind the computer, archives, and all the other things where you start looking what is already out there as knowledge. But it may also be that you do the desk research in terms of what is already out there in measuring equipment that I can use to measure. And then the next desk research is actually the research in the lab of your department, which is, have we got that? And where is it? And does it still work? Every time you look at those research methods, you have to make key decisions. How deep am I going to go into the material, or how wide am I going to scope it? To make those decisions, your research questions should help. They should tell you, because you've quantified them sufficiently enough, how wide and how deep. Be very careful if your questions didn't give you that answer. Then you may have to stop your technical design and check back on your research questions if they're sufficiently sharp enough and focused enough. Because the risk is that if you haven't done that properly, that your research is too wide. So basically everything you've researched sort of stays on the surface and it doesn't really go into any depth. And although it's nice what you've done, the scientific value is very limited, because you've just basically said, oh, well, this could be it and this could be it, and there is some evidence, but you've never gone into depth. And therefore sort of the academic rigor starts missing. But on the other hand, that might be exactly what was needed for the assignment. So that's where it's really important that you make sure that you have agreement on your research questions also with your supervisor, so that when you come to the technical design, where you're going the breadth versus depth decision, that you can make that based on the research questions that you have. The same with how much qualitative, what do I see, versus quantitative, what can I number? How far am I going to go? When is just my judgment enough? And when can I actually prove it? For me, for instance, I have a thing with people writing, there are significant differences. If I'm ever in your master committee, if you write the word significant, I better see some statistical analysis to back up what the significance is. Because if you just use significance in terms of there's a large difference that I've observed, then please write there's a large difference. Significance is associated with that you've actually proven a bit more than just the observation that one is much larger than the other. You've actually proven that there is a statistical significance, there's a mathematical evidence that the difference means something. And then of course there's the empirical versus the desk research. Desk research is basically what's already there. Empirical, what can I find? What is out there? So decisions need to be made. And it's important that you document them. Why? Well, people have a habit of asking you just about when you're finished, why did you do that? And then you want to know, you probably won't remember because it's been 4 or 5 months ago, or sometimes even longer. Then it's important you go back to your logbook or wherever you keep your notes and go, yeah, no, we made that decision because of this, and that was in the frame of our research questions, and you make very sure that that's there. In fact, if you write it up well, those things can automatically go into your thesis for the next phase. And you don't have to write that down again. So part of your thesis are basically already finished. So how do I find my methods? Well, the good thing is there's lots of people around you to inspire you. You can look in literature, you can look in your group's research traditions. If everybody uses Abacus to solve their finite element models, Well, that may be the one you also want to use unless there is a specific reason not to. Why? Well, the license is paid for, there's people who can help you, and there is a good basis because you've been taught it as well. You can also look, if you're looking at doing new stuff, what others have done in the past, other research institutions, and what their experiences are. That also saves you from reinventing the wheel. If you are trying to use a testing method that time and time again has been proven unsuitable for this, it would be great if you knew that before you started rather than out of it. And especially if you're in industry, you may have this perfect theoretical thing that you know will work, but if industry is not willing to pay for it, or can't afford it, or isn't part of something that they're familiar with or are allowed to use in their particular line of work, because of safety rules, then you can't use it. So there's also a point of compromise. But basically, when you are looking for a method, get as much information as you can. You have the pros, you have the cons. You carry out a well-argued trade-off and you come up with, this is what I propose to do. And then again, make sure that you get agreement at this stage of, is this right? This is what I want to do. And then get a yes or a no. Of course, you shouldn't be doing that for every little tiny decision. The idea is that at some point, in one of the many meetings you have, you go through this whole list. This is what I want to do. This is how, etc. Listen to the feedback. Not because you have to do exactly what we tell you to it, but there might be something in there. There is a reason people start arguing with you that they don't agree. There's usually two reasons. One, you made a mistake. It happens. Or two, and that's to a certain extent you also made a mistake, they misunderstand you. And then you may argue, but they should know. Yeah, but for one reason or the other, they didn't understand what it was that you set out to explain. So you have to start again and think about, how will I explain this again that it's better? Or you ask them why they have objections. Ask them and ask for alternatives, etc. So also when you select a method, check again back with your research objection question. Does it do what I wanted to do? Does it help me find out what I need to find out? Very importantly, is it reliable? Does it produce reliable and valid results? There might be a measuring tool that does something, but if you see literature that everybody goes, yeah, the results are scattered so widely that we still have no idea what we're actually measuring, then maybe that is not the one you want to use if there is something better out there that you can also use. Oh, in that sense, is it proven? And if it's unproven, what is the risk associated with that if I try that? Is it what your method of sufficient academic level? It's very simple. If my 5-year-old can do this, then you really do not want to use that for your academic thing, because it really doesn't add that much to it. The other thing is if it's financially affordable, ethically acceptable, can you use it in the time you have allotted? Because if you said, oh, well, I want to use such and such wind tunnel, but however, currently it's been rented out or in use for an EU project for the next 5 months, then you may need to think again whether or not you can do this method and you need to find something else. It's also important that you look that it is within your capabilities and that you are actually allowed to operate certain equipment, because can you do it within your experience? That also goes from when you're programming or using certain software. If you've never used the software before, and you think, oh, well, it will take me a week, I think by now you should be realistic enough that most of the time it will take you weeks, if not months. So if you see this coming, maybe you should first see if there's a course still available you can take and have a more efficient training before you start, or whether it's possibly better to use something you're more experienced with. Another thing, a very important one, can you get help on it? Because if you're doing something new that nobody else has done before, that none of the staff know anything about, none of the technicians know anything about, and there is really no immediate support for you available, that means that you're taking one hell of a risk with your research. That's great if you are willing to take that risk, but there's a very large chance that when you end up a creek without a pedal, that you're stuck and there is nobody there to come and back you out. You might actually have to completely scrap what you've been doing and start again, because there's nobody that can actually help you. So make sure that that is also within the realm. And I'm not saying you shouldn't be doing something adventurous. I'm not saying you shouldn't be doing something That is new, but be aware of the limitations. It is a master project. You have to prove to us that you can independently carry out scientific research. We are not asking you to immediately get yourself nominated for the next Nobel Prize or the next field medal. So, when choosing methods, it's okay to be ambitious, but please be realistic. Then the research materials. There are many options available. Again, check back to your conceptual research design. What is the framework within the plan? What is available? What is the cost? What can I use? What can't I use? How long does it take for it to happen? For instance, if you are going to look at human factors in an engineering department of an airline, the maintenance department, and you want to talk to all the engineers for 3 hours each, good luck with that. These guys are busy. These guys have been planned in usually months beforehand. So if you want 3 hours each of their time, is that actually going to happen? And also, why would they talk to you? Most of these departments see students coming from every polytechnic and every university every week. So that's again somebody who wants to talk to you. So look at those things too. What's there? What can I get? What's the delivery times? If not, is there a suitable alternative that gives me exactly the same answers that I'm looking for? So some creativity and out-of-the-box thinking may be required here too. Then look at data acquisition. Your research strategy should tell you really what the data is that you want to gather. What is it that you want to measure or study, etc. And from that, it should also tell you where you're going to get your data from and your research population. And for those of you going, oh, this is social sciences research, research population is basically what you study. That can be piles of material, it can be a whole set of theory, etc. But you pick something from it, and data comes from it. And again, from your planning, it tells you what the time frame for all of this is. So how much data can I get? So that also, again, limits what it is that you want to do. And limit in this case is a good thing. Because research is woefully addictive, great fun, but it can also wear you down. So it's important that in order to stay on time and on plan, which is what you're going to have to do the rest of your grown-up lives when you work, if you're successful in it, is to make sure that you constantly look, does it fit within my framework? By the way, all those brilliant ideas that don't fit in your framework, write them down. They make for a great recommendation section. I can't stress availability enough. I've seen very ambitious plans that went completely to smithereens because people didn't check whether what they wanted to do was available to them. And it's really hard if you've really had your heart set on something and it doesn't happen. So in that sense, the technical research design part is the fun part, but it's also where you have to be realistic and you may have to make some very harsh choices. Again, that's not a problem as long as you're still able to answer your research questions. If that isn't the case, then you may need to go back to your supervisor, and you're better off doing that in the first few weeks to go, look, you wanted me to do this and this, but in order to do that, we agreed that I was going to use this equipment and that equipment or write this and this code. But I've looked at it and it's going to take us this long and that long, and then I'm out of scope. Can we make adjustments? And you come to a common solution together. So in that sense, that is exactly what it is that you are looking for. So I hope the technical research part of this is now become a bit more clear. The next section will be on ethics, which will also give you a bit more idea of where all the ethical considerations are for your research and whether or not you need to get permission. So after you've completed this part, you can actually start on your research design and start looking at things. So good luck for now. See you next time. Bye.